Hey everyone, I'm Kyle. Today we're going to be talking about building an AI agent with Dagger to actually help with developing Dagger. And so the thing it's going to be doing is generating translations and examples for Dagger modules. So first, talking about the translations, what is the problem we're actually trying to solve with this agent? So if you're not familiar with Dagger, that's okay. The main idea is that Dagger has many SDKs and many languages. And in the documentation for Dagger, we need to show reference for every single one of these SDKs. Right. So here's a snippet from the docs where we can see it's talking about a particular use case for how to do something in Dagger, and there's little tabs that show the same implementation in each language that we support. So why is an AI agent an appropriate solution for this problem? Right now, the translation process is manually done by humans, and it's a frequently occurring task. So whenever we have something new to document in the Dagger docs, we need to actually write those snippets in every single language that need to be displayed on the docs. And then as you can see in these little snippets, the Dagger API is well defined and it's really similar between languages. So that means an LLM should easily be able to figure out how to take the Python code on the left and turn it into the TypeScript code on the right. And so what should our agent do in this use case? So we're mentally designing this agent to solve this translation problem. So our input is going to be a Dagger module that needs to be translated and the language we want to translate it to. Its work is going to be, we're going to give it enough information to be able to translate modules. So we'll give it a bit of information about the SDK for the language it's reading and the language it needs to write in, and things like that. Then it's going to generate this translated module. So it's got some code. It's going to write some code in a new language that does the same thing as the source code. And then it needs some validation loop. So we need some way to say, this code that you generated, is it valid? So we'll have some validation function. And then if it's not valid, we need to give that feedback to the LLM so it can iterate on its code until it is valid. And then once it's valid, we'll output this translated Dagger module. So let's look at our translation demo. So to start with, for this application, we're using this hello Dagger module, and it's a simple module that you can call hello, and it gives you greetings using Figlet. And so this module right now is written in Go. So I've checked out the module to my local code base, and I'm going to see, here's the Go code, just like we saw in GitHub. So this is the Go code that we want to actually translate to another language. So I'm going to use my agent, and we're going to look at the code for that agent in a moment while this is running. And my agent is at github.com/kpenfound/Dagger Programmer. And that agent is going to be using an LLM. Right now, I'm in the Dagger shell. I can say, what's my default LLM right now? And it's going to, on another screen here, ask for my 1Password fingerprint. And now it can say, okay, by default, we're going to be using Qwen 2.5 Coder 32B because on my workstation, I've set that up as like my default model with Olama. So we're going to use my module, the github.com, kpenfound, Dagger Programmer, and we can see what functions this has. So it has the ability to translate and write examples. So let's start with the translate one. We can say .help translate, and it takes in a module and the language we want to translate to. So if you remember from our requirements that we talked about, these are the two things that we need it to take in, and then it's going to give us back a directory. So we'll give it our current module. So again, I have checked out that module to my local workstation, so I can pass in the current working directory which is a Dagger module. And then the language, let's see, it's currently in Go, so let's translate it to Python. And then this gives us back a directory, so let's just look at the contents of that directory. We'll say entries. So what do we need to tell it? The function is translate. So we've told it to translate the current module into Python and then show us what's in that directory that you've output. So while this is running for a moment, let's start looking at the code. So here's my code. This entire agent is self-contained in this one repository. So there's no like external libraries doing all the heavy lifting. This is all self-contained. We're just using Dagger and its primitives to create this whole agent. I will highlight right here that this current version of Dagger is very experimental. So if you're watching this like a day from now, some of the syntax might be out of date, but the ideas and the mechanics behind it are still going to be sound. So make sure if you're watching this video to go look at the current documentation for how to do these things with Dagger for whatever the current version is at that time. So we have in this Dagger module our translate function. If you remember, we passed in the mod and the language. There's also an optional argument for dependencies. We'll talk about what we're using that for in a little bit. So our first step here is getting some information from the module we passed in, like its SDK and its name. So for the one we passed in, we know it's called hello, and it's going to be go. And then we create a workspace. So this is basically an environment and a set of tools that we're going to give to the LLM. And so like I said, this is all self-contained within our project. We're not like using some external library that's giving us like a coding environment for our agent. This is literally in my code right now. We're going to write this environment for it to use. And so we take this workspace and we give it to our LLM. So we've got our Dagger client. With that client, we're taking LM and giving it our module workspace. And what is a module workspace? It's a thing I wrote. It's a submodule right here. And it's written in TypeScript. If you didn't know, Dagger works multi-language. So this Dagger module I wrote in TypeScript is now callable from Python. So in this workspace, this is basically the place where we want the LM to be able to have an environment where it can actually do its work that we've assigned to it. So we have a constructor where we give it like our the SDK and all these things we wanted to be able to use to write its assignment. And then we give it a few functions. And so in my experience working with different models, the best way to guarantee a higher rate of success is to narrow down the scope as much as possible for that LLM. So it doesn't need to worry about, oh, I gave it a whole Docker container and it has all the tools of a Linux environment and it can write files. What I'm giving it is just the ability to write content. And I've even given it a specific file that it's working in. So it's not even saying I'm going to write content to whatever file I want in my workspace. I'm saying, you give me the content, I'm going to figure out where it goes because I know that this is a Dagger module workspace. So its first function is write. It's able to generate up some Dagger code, write it to its workspace, and this will save that code to the workspace. It has a function read, of course, so it can read what its code is currently in its workspace, and then test. So this is the validation loop, right? It can test its workspace and see is it passing whatever validations me, the author, has come up with. So in this case, it's running Dagger functions, which basically loads up the module and makes sure that it loads. Like that's literally it. We could go even further with this. We could say make sure Dagger functions matches the output of the original module you're translating. But for this example, we're just making sure that it loads. And then a user reviewer could make sure that it looks okay in the end. And then if it fails, we're going to send back the error so that the agent can look through that error and figure out what might have gone wrong. And if it passed, we just say test passed. And so this set of code here where we pass in the workspace, we give it a bit of information. Like I said, we're telling it some information about the Go SDK, some information about the Python SDK. So this is like contained within our workspace here too. So like here's a little markup about like here's some tips and tricks on how to use the Dagger Python SDK. So now our LLM has a workspace that has this context of how to write Dagger code. It's got our prompt. We're basically setting our constraints and giving it its assignment. And then that's it. So, and we get back the workspace when it's done. So this set of code here is going to do the entire loop of taking the assignment, generating the translated code, validating it, and if the validation fails, it'll keep going until that validation passes, and then in the end, we're going to get out our translated code. And just to be sure, because this is like a thing that we want to be able to use as developers and know that it's definitely good code it's outputting, we're just going to manually run the test again after the LLM is done with its work, and then we're going to return that directory. So let's go back to our terminal, and it looks like it failed, and that's okay. So it tried a bunch of things, and let's look at the actual output here. So we can pull up this run in Dagger Cloud just to get a good trace of like what actually happened. So we can see the things we typed at the beginning of like getting help for how to use Dagger Programmer. And then we actually ran the translate function. And then here's the context we gave it on using the Go SDK. Here's the context we gave it on using the Python SDK. And then here's its main prompt of saying, here's your assignment, translate this code. And then it runs test, that fails, and it says, okay, let's go ahead and translate this. It tries some things, and eventually outputs a whole bunch of stuff and gives up. But this is okay because the really cool thing, so like this is using, like I said, it's using Ollama Qwen 32. This is our output from when it ran test. We can see that it never actually wrote its file to the workspace. So basically that LLM itself maybe got overwhelmed with the amount of context we gave it, but it failed. But now I can go back here and say, okay, we had an optional argument for our module called model. So if I'm running this and I'm seeing, okay, Qwen 32 is not really having great success with this set of prompts and this amount of context, maybe I want to pass something else in. So in this case, I'm going to give it, let's say, model. Let's give it Gemini 2.0 Flash. 2.0 Flash. And so now it's going to run the same assignment, but instead the LLM in this case is going to be Gemini. And maybe with its ability to take in more context, it'll be more successful at solving our problem. So while this is running, we'll just fast forward for a second to this being complete. Okay, and it's done. So we can see that it wrote some things. We can go back and we just asked for the entries this time, which we saw a source, but we can actually just remember it's returning a directory. We can just ask for a terminal in that directory. Let's say, so instead of saying entries like we did before, we're going to say terminal, and it's still the same prompt. So everything it just ran is going to be cached because we just did all this work. And so now we're in a terminal with that completed work, and I can say, okay, there's source. Let's see what's in that. And there's hello. And there's my main.py, which is source / module name / main.py is like the default path for a Python file in a Dagger module. So I could look at that. And we can see, let's go back. So it has a class hello, and it has a function hello, which takes in a bunch of arguments like greeting, some optional flags, and then it'll output this message. If we go back to our original hikes hello, if we go back to this original one, we can see that it should look exactly the same, but this one's in Go. So we've got those optional flags. We've got some conditionals based on those flags, and it's going to return that message. So we've successfully translated that code to Python code. So that was only step one of our agent. But don't worry, the second part is going to be really quick because we're going to take this and say, okay, step two, we want to generate Dagger examples. And this is kind of building on our translator. So what is the problem to solve? We have this thing called Daggerverse. It's an index of publicly available Dagger modules. In the Daggerverse, if you go to a specific module, you can see documentation on how to use that module. So it'll show each of its functions, the arguments for those functions, and so on. It can also show code samples for how to use those functions in code, provided that the author of that module has written these code samples in each of these languages. So if you look at this little snippet from Daggerverse, you can see for this function called service, we have tabs for Go, Python, TypeScript, and Shell, and there's some example code using that service function. And so as the author of this module, I've written examples for all of those languages that are in those tabs. So why is an AI agent appropriate for solving this? Example code files are complete Dagger modules for each language. So when we saw those different tabs, each of those tabs is a Dagger module in itself that provides functions that show how to use functions from my original module. So if I'm a module developer and I have a module that I want examples for, I go from maintaining one module to maintaining that module plus each of the example modules. So creating each of those and maintaining them can be cumbersome. Second, the module that you're writing examples for has a well-defined schema. So like I said, Daggerverse already knows how to show what each of the functions are, what the arguments are, and so on. Dagger itself can introspect those things really easily. And we already have an agent that can write multi-language Dagger. So we should be able to take in a module, look at its schema, and write example modules for it in each language. So let's go step by step once again to figure out how the agent should actually solve this task. So we're going to input a module that it needs to write examples for. We're going to give the LLM enough information to be able to write examples. We're going to generate an example module in one language. We're going to validate it and iterate until that validation passes. And then once we have that valid example in one language, we can use our existing translator agent to translate that one example into all the different languages that we want to show. And then our output is going to be a directory with several Dagger modules in it. And so just to show the flow chart like we had before, we're going to have an agent generating examples in this validation loop. And then when it's valid, we go out to this second validation loop, and that's going to happen for every single other language that we want to show. And so it's going to create all of these different examples based on the first one we generate that we deemed was valid, and then return all of them. So let's look at our examples demo. So once again, we have this, and we can say .help write examples. And it'll show us, okay, it takes in a module and returns a directory. So let's say write examples, again, with our current module that we're in our current directory. And once again, let's get into a terminal with the output of this agentic workflow. So we're going to let that run for a second. We're going to look at the example code. So that's going to start running. You can see it already loaded up its workspace. And it's going to start doing the LLM things. So let's go really fast because I bet it's going to be a quick job. So here's our function, write examples, just like we just called from the shell. And again, it takes in a module. And so just like before, we're going to start by looking at this input module and saying, okay, we're going to write an example in Go, regardless of what the input is. And we're going to load up the input module and figure out what its schema is, what its name is, and its source directory. And then once again, we're going to get a workspace that we can give to our LLM below. So we've got our workspace. It knows it's creating a Go module called example. It has a dependency on our input module. So in order to write examples for an input, you need to have that input as a dependency so that you can call it, and so on. And so we've given that workspace to our LLM. We've given it some context on how to write good examples. And then we have yet another prompt that basically gives it its constraints and some rules and says, here's your assignment. And once again, this itself is doing that whole loop of, it's going to generate an example module. It's going to try and validate it in our workspace. And we already saw what that workspace looks like. And then once it's deemed valid, it's going to come back and say, okay, here's my example. And then again, we're going to manually double check just to make sure that that thing it gave back is indeed valid. And then we're going to do a bunch of things in order to be able to give this example to our translator. And then we just have a loop that says, here's the other languages. Remember, we started with making an example for Go. Here's the other two languages I want examples for, Python and TypeScript. So it's going to loop through those. It's going to call that translate. So this is now, a little multi-agent DAG where it's calling out to our first agent translate and saying, your input is this example that I just generated. Give it back to me in Python or TypeScript as it's looping. Once this thing has gone through its own agentic loop, it's validated, it comes back, and we say, okay, now we're going to add that to our directory of all of the examples. And then in the end, we're going to return that thing. So we come back, and it looks like it failed. So we can see, let's go once again to look at this cloud to see maybe why it failed. So here's our translate. Let's collapse that. Here's our, let's see, translate. Okay, now we're translating again. That was our terminal session earlier. Okay, here we are. So now we're writing examples. So we gave it the context on how to write examples. We gave it, let's see, all this context says this is how you write good examples. And then your prompt is these rules, and then it wrote, this was its example. And we could see some of that in like the output from the agent itself. But it's writing this Go code that says, here I'm calling the hello function with empty ops, and then it ran test. And then test looks like it passed. Excellent. So what's wrong? So then we're going to pass it to the translator. So it looks like we're giving it context for the Go SDK and the Python SDK. And the translator it wrote some Python code of the same examples, and it looks like that passed. And so now we're going to call the translator again for TypeScript. And let's go down, and it looks like that failed. So we can try to dig into that or just give it another shot. Right now, this agent, we don't have like a built-in why don't you just try again kind of logic. So let's pause, and I'll run it again, and we can see the hopefully successful output on the rerun. All right, so it looks like it passed. Let's look at what's in this directory. And so it has all of our different files in it. Let's just have a quick peek at them real quick. Let's say cat examples, go main.go. And we can see that it created functions for each of the different ways of calling that original hello function. So here was one without any arguments. Here's one where it passes in greeting is yo, name is Bob, giant true. So it was able to look at the schema for our hello module and figure out all the different permutations of how you might want to call that module. And then actually took this, and let's look at maybe the Python one. Python sample main.py. And so we then took that Go and translated it to Python and TypeScript. And we can see that it's doing the same thing here, but in valid Python using the Dagger SDK. So now we have this in our little terminal. We've been able to look at it and validate it. But let's say I actually want to add this to my module now. I can actually say, okay, instead of a terminal, we at this point in our shell, we have a directory. So why don't you just give that back to me, and I can commit it to my project. I can push it to Git. I can make some modifications, whatever I might want to do from here. But let's just say export to my current path, and it's exported. So now if I exit the shell and look at what we've added, so in my local Git state, now I have this examples directory. And I can tree examples and see that it's exported all those files to my local path. So now I can git commit them. I can make some modifications if I want to add some more comments or change how some of the examples are formed. But anyway, we have this exported back, so I can now push them to Git, and now they'll actually show on Daggerverse in that examples tabs. So now that's it for the examples. So we've seen Git translate. We've seen translation from any module to any other language. We've seen writing examples that then generates one to Go and translates it to all the other examples. This helps me and my team actually develop the Dagger docs and develop modules themselves. So we have an agent that can help with all this work. All of this code is available at github.com/kpenfound/Dagger Once again, disclaimer, the code that I showed in this video is like on a current experimental version of Dagger, so this API might change day by day. So make sure if you're referencing this video, go and look at the current Dagger documentation for how things work at that time. And then visit dagger.io and join the Discord, where we're all working on things like this all the time, and hope to see you there. Thanks.